So now let's have a look at a scale variable or a continuous variable. Let's look at age to start with. And often we're interested just in the age distribution because we just want to know more about our participants, because that will affect how we interpret the results. So what was the age range of the people who participated in this study? I'm going to reset this. Now we've got a few options for what we can do here. I'm going to start with a histogram. I feel like that's a nice way to get sort of an overview of what's going on. So let's just do age by itself. So we have people, probably there's a, you'll often find with age distribution there's a cutting off at 18, and that's just because for ethical reasons most studies will sort of restrict themselves to adults, but we didn't have any that young. So we're going from around 22 or something, whatever that is there, all the way up to 70. So that's quite an age distribution there. Things you can do with histograms. If you don't like the way that the data has been chunked, because it's grouping people into what we call bins, so each column here is a bin, so everyone who fell between, I want to say, I don't know, like 22 and 25 is falling into this bin. If we want to change the number of bins, we can do that through the chart editor. So if I click on, let me double click again, you'll see this little tab up the top called binning, and it's doing it automatically, and often it's perfectly fine and you can just leave it. Or you could try, just to illustrate what I'm talking about, if we just change this right down to, let's say, 4 bins. So it's dividing everyone up into these 4 chunks. Actually, it's gone just over the decade gap. I wonder if we could make that. Oh, we could say interval width of 10 years. Let's see what that does. So that's a nice way to look at it, actually, because we've got 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. So that's a nice chunky histogram. Maybe you want to see them in intervals of 2 years. And this gives you a finer level of detail, but it's a little bit more difficult to see if the data is approximately normal, which is a little bit hard to judge anyway when you've got a small-ish sample size. So to my mind, this is too fine because I can't see the pattern that it's making because it's breaking it up into too many groups. Let's try widths of 5 years. And I think that might be where we started. Oh no, it was a little bit different there. So that's fine. But honestly, I actually like for this particular one, I don't know, I like the 10-year one. I'm going to leave that. And you can see that the histogram also gives us the mean and the standard deviation. We talk more about that in a couple of weeks. If you don't want this information on the graph, you can just delete it. You should be able to just delete it. No, what have I deleted? And now I've mucked that up. But anyway, undo is a wonderful function. So just undo if you mess it up like I did. That's looking all right now, actually. I'm happy. Oh, I've chopped the top off somehow, but apart from that, it's all good. So that's a histogram. Let's have a look at another way of looking at this data. We can't just do plain dot plots. Tend not to get, these are, I don't know if these are old-fashioned, they tend not to get used a lot. This is where we actually put a dot on for each person. It can be a little bit more difficult to see the patterns it's forming if the data's very spread out, and you tend not to have, those dots are huge. I often change my default settings depending on what I'm trying to do. I don't know if that was me or if that's something in there, but they're massive dots. Let me turn them down a bit. Oh no, now they've gone tiny. That was bizarre. So now we actually get a dot for each person. Now maybe we would want to see a bit more detail here, just so we could read off. See, I probably wouldn't use this in this context, but there is some reason, maybe you do need to show something for your particular data. If you've got a really big data set, then the dot plot will look pretty much the same as a histogram anyway, so it doesn't matter. But in this case, we can actually see, look, there were 2 people who were 24. There were, I don't know, is that 5 or 6 people who were about 33, so you get a lot more finer detail. And I wonder if these have been binned actually, because they're falling into groups. That would be, probably should have a look at that another time. So you can do a dot plot. They tend not to be used that often. We usually use histograms, and box plots are very handy. So I've had a couple of questions about box plots, so let me reset this. We're going to do a simple box plot here. And we've only got one option for where to put it, the variable that we're interested in. So let's drag in our age. Okay. So the box plot is dividing the data up into groups of 25%. So I was just trying to think of the best way to explain it. Probably easiest if you Google a diagram of where the percentiles lie for a box plot. So this line here is the median, which is the middle person. So if you think about lining everyone up from their age, in their order of their age, so the youngest people are here, and they line up all the way to the oldest person up here. This line here represents the very middle person. So it's not necessarily the same as the mean. So the average age could be different. If it's skewed, the mean will get pulled in the direction of the skew. If there's outliers, they'll pull on the mean as well, but the median tends to be fairly stable, so it's a nice measure to use for the centre of a distribution if it's not symmetric. So that's the middle person. So this is the youngest 50% of the people, and this is the oldest 50% of the people, and then each of these is also divided in half. So this is the youngest 25%, then the next 25%, then we've got the middle person, next 25%, and then we've got the oldest 25%. And we call these quartiles because it's dividing the data into quarters. And we just put the box here because it's often of interest to see the middle 50% of the people versus the sort of what we would call the outer 50% of the people, to see how spread out it is. So this is often called a box, and these are called whiskers. So this will often be called a box and whisker plot. So we've looked at one continuous variable, but what we are more likely to be interested in is comparing the age distribution across the treatment and control groups. Because if everyone in the control group was aged 50 to 70 and everyone in the treatment group was aged 20 to 50 or whatever I said, then obviously that's going to impact on how we interpret the results. So we're looking to see, do we have a similar age range in the two groups? Now, histograms are a funny one. I really don't like these ones. You can use a stacked histogram. You can use a population pyramid, and I might just quickly show you there's one other dialogue you can use to get histograms split into groups, which is very handy, and we'll use probably a lot later in the course. So if we wanted, before we just use the plain histogram, if we wanted to look at the two groups, we could do it using the population pyramid. So let me drag age into here, which is the distribution variable. So we want age spread out along this axis, and we're going to split by group. And we've got a similar range of ages in both the groups. The treatment group happens to have both the youngest and the oldest people, and that's probably just, if they were randomly allocated, that'd just be a random chance. So the other way we could do this is actually not through just about every single graph we do, we through Chart Builder, but there's one very handy graph down here in the legacy dialogues. And it's this histogram right at the bottom because it lets us stack the histograms vertically. So if we did the, put them after age and group into the rows, you'll see that we get it stacked this way. So I find this to be a really, really useful graph. It's a shame that it's not available through the chart builder. But we'll do that more later in the course. If you don't like that one, you don't have to use it just now. let's go back and have a look at the box plots. I'm going to reset that. I'm going to go down to box. And so we did the simple one before. Now we want to have it split into groups. So we will have the age going up and down the y-axis, so we're going to drag that in there. And the groups that we want it split into are the control and treatment, so that's along the x-axis. And so we're seeing what we saw before in the histogram, that the oldest and the youngest people happen to be in the treatment group. And so the control group looks a lot more, I guess, it looks less variable than the treatment group. In this particular case, that really wouldn't concern me because they had a fairly small sample size. If you were getting this pattern, I think, with a much larger sample size, then you might be wondering about the allocation process. But for a small sample size that had less than 50, to get this difference is not unusual. Okay, we've hit the 11-minute mark again. So what I might do is stop the video here, and then in the next one I'll have a look at doing two continuous variables together, which you might not need at the moment, but we will be looking at later in the course, so we may as well have a quick look now.